Hi, welcome to my final project presentation. My name is Nik Ammar Ikhwan and the title of my final project is Concept Design of a Cargo Box for Lorry. This presentation will contain abstract, introduction, objectives, scope and implementation, methodology, result and discussion, and I will end this presentation with conclusion and recommendation. I will start my presentation with the problem that happen nowadays. Some cargo boxes on the market cannot be detached or separated from the lorry itself, or they use permanent type of attachment that can be classified as welding. Aside from that, majority of lorry owners in Malaysia purchase cargo box from overseas due to the use of lightweight material such as aluminium, and because of this, they had to spend more money to the high cost of shipping and the expensive material. In addition, the negligible difference between gross vehicle weight and the curb weight, as indicated by JPG Malaysia, might be used to overcome these issues. To overcome this project will help lorry owners to reduce the cost by the usage of cheap material that easily obtained in Malaysia, which is mild steel as the frame of the cargo box. This project also helps in the design of detachable cargo box that can be used into various types of lorries by using some attachment. This project focuses on 1 ton and 3 ton lorry, which are both classified as truck delaying vehicles since their gross vehicle weight is less than 3,005 kg, while curb weight for both lorry is up to 7,500 kg. Table below shows the standard and the maximum dimension for both class of lorries. The objective of this project are to identify a detachable cargo box that is compatible with both 1 ton and 3 ton lorries, to select a potential production method for the cargo box, and to analyze the critical connection component between the lorry and the cargo box. Next, we move to the scope and the limitation, where this project will concentrate on the design of 1 ton and 3 ton lorry only. The design of the cargo box will not exceed the typical length of 1 ton lorry in Malaysia, which is 4,525 mm in length, 2,500 in width and 2,150 in height, as the maximum dimension of the cargo box is different to each other, as JPG has stated. CATIA version 5 R20 and NCIS 2022 R1 will be used to model the updated project in 3D and perform the final element analysis since there is no fabrication process. Dimension of I-beam, C-beam, square hollow section, angle steel and corner angle were following the standard size. For some parts, which is square U-bolt, bolt and nut, need to be edited to make it simple to reduce the time when analyzing the design using NCs. By removing the thread and the edge fillet of the design. The limitation of the project is there are no previous research about the analysis of the cargo box frame that makes the result of analysis cannot be compared to other researches. This is the flowchart of the methodology of this project. The study site with identifying the size and some of other important specifications of the cargo box. Specifications for product design are a vital instrument for assuring the success of this study. By examining and gathering the essential needs of the end product, the activities in designing the cargo box are become faster, resulting in efficient development process. The table shows the product design specification of the cargo box. The PDS has a significant impact on the duration, cost, and success of the product development. This step will accomplish the first objective of this project. Next phase is the selection of the material. The table shows the property of mild steel, alloy steel, and aluminum that obtained from NC's software. Mild steel will be used for the frame of the cargo box and the frame of the door of the lorry. Aluminum will be used for sheet metal, angle steel, and corner angle steel. And alloy steel will be used for the attachment, which is square U-bolts, bolts, and nuts. For the design selection, morphological chart were used to broaden the scope of the search for potential solution to a predetermined design issues and organized method of ideal creation. Design is then evaluated using the weight decision matrix, which rank the design criteria with winning factors and assign a score to each idea based on how well it satisfies each creation. This step will accomplish the objective 2 of this project. Next, preliminary design enabled this project when it used to establish the approximate size, weight, force load restriction, and other physical parameters of the cargo box in order to optimize the result of the analysis, while the detailed design will include the 2D and 3D models and the estimate cost of the project. The table shows the weight and the cost of each part of the cargo box. In this project, NC software were used to analyze the cargo box together with the attachment to determine the maximum deformation and the maximum wall mixture stress. Three different situation analyses were conducted, which is static, emergency brake, and cornering. The figure shows the direction of the exerted force for all situations. There are the sample calculation used to calculate the force. This is the result of static situation that analysis conducted on the frame of the cargo box only. As stated in the introduction, the curb weight of 1 ton and 3 ton lorry is 7,500 kg, while the gross vehicle weight of them are less than 3,500 kg max. The maximum load can be loaded into a cargo box is 4,000 kg, while half loaded is 2,000 kg. The maximum deformation happens at the back side of the cargo box, while the maximum volumetric stress happens at the bottom of the frame that have been welded into two horizontal I-beams. Both the deformation and volumetric stress is increased when the number of the load increases. For the emergency brake situation, the first analysis was performed on the frame of the cargo box and the attachment when the lorry performing emergency brake from different velocity to fully stop in 2.5 seconds to obtain the maximum deformation and maximum volumetric stress. The maximum deformation happened at the front side of the cargo box as all of the force exerted to the front into X direction, while the maximum volumetric stress happened at the bottom surface of the square U-bolt as it holds both cargo box frame and the lorry chassis, makes it receiving the highest volumetric stress compared to other parts. From the graph, it clearly shows that deformation was increased as velocity is increased. The value of volumetric stress dropped when the velocity reached 110 km per hour. It can be concluded that the square U-bolt efficiently holds the frame and the lorry chassis when the velocity is 80 km per hour. The value obtained for the stress for other velocity is acceptable as it is still more than 900 MPa. The second analysis was performed for the emergency brake to see the difference in deformation between when using attachment and when permanently welded. The value of maximum deformation when using attachment is slightly higher compared to the value of the maximum deformation when permanently welded. It shows that the performance when permanently welded is better because of the contact surface is bigger when the force exerted to the front. For the cornering, the first analysis was performed on the frame of the cargo box and the attachment when the lorry cornering at radius 60 meters with different velocity to obtain the maximum deformation and maximum volumetric stress. The maximum deformation happened at the left side of the cargo box as all the force exerted to the left into Y direction, while the maximum volumetric stress happened at the bottom surface of the square U-box. From the graph, it clearly shows that the deformation was increased as the velocity is increased. The value of volumetric stress dropped when the velocity reached 55 km per hour. Even though the highest stress is when the velocity is above 70 km per hour, it can be taken out as the maximum velocity of a lorry can move on a circular path of 60 meter radius is only 55.2 km per hour. A higher velocity than 55.2 km per hour will make the lorry slipping from the path. It can be proved by using the formulas stated in the slide, where the coefficient of static friction between the tires and the road is assumed to 0.4. The standard acceleration of gravity is 9.81 and the radius is 60. It can be concluded that the square U-bolts efficiently hold the frame and lorry chassis when the velocity is 40 km per hour. The value obtained for stress for other velocity is acceptable as it is still more than 900 MPa. The second analysis was performed for the cornering to see the difference in deformation between using attachment and when permanently wet. The value of maximum deformation when using attachment is slightly lower compared to the value of the maximum deformation when permanently wet. It shows that the performance using attachment is better because of the contact surface is bigger when the force exerted to the left. For the conclusion, this project has effectively accomplished all of the objectives. The frame can hold the maximum load as the frame maximum stress is lower to yield strength of the mild steel, which is 250 MPa. The attachments are sufficient to hold the frame and the Lorry chassis. The first improvement that can be done is by increasing the diameter of the square U-bolt. The second possible improvement is to increase the number of the square U-bolt used as the attachment. These two improvements have been analyzed and has been put in the technical report. For further enhancement for this project, airflow analysis by using computational fluid dynamics can be used to analyze the shape and the dimension of the cargo box. The previous research shows that shape and dimension of the cargo box is important to reduce the air resistance. ANSYS software can be used to conduct this analysis. I think that's all from my presentation. Thank you.